Yo, what's up, everybody? Welcome back. Today we are working on generating some messed up looking barcodes. So the idea here is that I want to scan things as I put them in my fridge. Then I have like information in my computer about how much of every ingredient I have. And as I use that ingredient and punch in like, oh, I used 50 grams of milk today. I'll be able to like generate things like, oh, I have this much milk left and this much cheese left and this much bread left. Like you can make this thing. You can make some bread cheese milk, right? And it can also say, hey, you're running out of this thing that you use a lot. You have no more spinach. Like let's put that on a shopping list for you to buy. Right, that's kind of the idea. And it turns out that scanning barcodes with your phone is not like incredibly trivial, right? Here are just some photos of things that I took in my house / at the store. And you have stuff like this, right, where it's pretty unclear if you were to just look at any individual pixel, if it's like in a bar or not. You have stuff like this where you've got like pretty heavy sensor noise. You've got like some like curved surfaces, some reflective surfaces. Sometimes the bars aren't even black; they're like aluminum and reflective, right? Sometimes you have like motion blur, which makes it so that the things that are dark don't look as dark as they should. And then also, like on top of that, like the printer might not even print a perfectly smooth thing, right? So all of these makes it so that like manual processing of these bars is not as trivial as you would think. I think still doable with like some intelligent image processing, but we're not intelligent around here, and so we want to ask a computer to do this for us. So we want to train a neural network, and we've kind of like built a neural network training infrastructure that is kind of almost ready to start training on something like this. But to do neural network training, you need data. Now you could go online and type in Google barcode dataset or whatever, and you like might get something that has pictures of barcodes and their bounding boxes, and like the codes that they are. But I suspect that as we build up from nothing into a neural network to scan these things, I think like a much simpler problem to start with is this pixel inside a black bar or not? And then we can work our way up to, is this pixel inside this particular black bar? And then we could work our way up to, maybe if we can get that working correctly, then we could go, what is the code from this thing? But that's kind of like, we have to start simple in my mind. And to start simple, we need data of where the bars are. And I'm not gonna like go onto some data set and like color in thousands of bars, right? Maybe even millions of bars, right? I don't want to do that. That's a pain in the ass. And so instead, we want to generate barcodes from nothing, and we then have the information of where all the bars are, but then they don't really look right? So yesterday we generated a barcode, but this does not look like this, right? In the slightest. And so we need to like take this and fuck it up, right? That's kind of the goal, is to make things that resemble real life barcodes that we can use to train the neural network, and then hopefully it will like work on real life barcodes as well. That's kind of the idea. So yesterday we're doing this in like OpenCL, which is kind of like interesting. I haven't really done like any image processing in OpenCL before. I've done it in OpenGL, but OpenGL has a bunch of stuff that comes with for free. But like the training stuff is in OpenCL, so it kind of makes sense for like our image stuff to be there too. So we might discover that's the wrong space. But as of yesterday, we have the ability to generate barcodes from. So the way this works is we create like 96-ish, I don't remember, 95 modules, and we do, sorry, where's my brain going? Dude, I just melted. Yeah, so we set each of the like black white pattern, and then we like sample that from a larger image and like extend that shit down, right? So you'll see there is a little bit of like, feathering on the edges going on, which is nice. So today I want to start like doing things like, instead of making an image of this thing, put this thing in a bigger image and do it at some arbitrary scale, rotation, and translation. And maybe then we'll apply some like noise to kind of warp the bars a little bit for, an example like this, where if I take my mouse here and scroll up and down, these things are not vertical. They're kind of like bowed in and out. So maybe we can get something like that. Motion blur should be relatively easy, and maybe sensor noise is another easy one we could cover. So we'll see. But yeah, that's the plan. With active learning, you wouldn't need to label as many barcodes, I bet. Maybe, yeah. But again, like, you need some like measure of correctness. And I think I want to start with that measure of correctness being like pixels, not numbers. And I think that there's no way around the fact that we just need data for that, you know? Okay, let's start by taking this thing, and maybe we should start by actually rendering this on top of another picture. I think that that'll make our lives easier a little bit. Um, yeah, so let's load a sample image, which we have the capability of doing. So we can go like CPU, what we have like somewhere in here, load image from disk is like probably a thing we have. CPU image.load. CPU image load, and I think we have some like just picture of a whale that we downloaded. We'll call this like base image CPU. And then we need to turn this into a buffer base image. We need to turn this into something that can be worked on in OpenCL land. So probably here we just go like math executor create tensor, and we put him on our allocator, and his initial data is base image data, right? This base image data is RGBA, and we need float data here. So let's do like we'll make some memory that we can play with, and then free that memory later. And in here, we're going to allocate some grayscale floats, I guess. In base image F32 gray. And we're allocating what? Some floating points, and we're doing like base image width times base image calc height. And then we go like for base 40 to base image F32 gray len. We do something. We go like base image F32 gray I is equal to what? We like take red, green, blue, sum them. Yeah. So this is like val plus equals this and this. We ignore alpha for now, and then we divide this by 285 times 3 is the max value. Right? Sure. Seems reasonable. What's he mad about? Yeah. Float from int, please. Now what's he pissed about? Float from int everywhere. Okay, and then now we create this guy. Base image GPU. Okay. So what's he pissed about here? We need the dimensions here. So this is going to be base image width, base image calc height. Okay. And then here we're using our grayscale shit. And then I think that these things want F30 or int32s, not U sizes, I assume. Okay. Now when we make bars, we want to insert this on top of an existing image, right? So here, I guess instead of passing in dimensions, we just pass in the base image. And we figure it out from there. Base. So this is gonna be like a math execute tensor or something. Probably. So that means that he's not really. Do we want to copy or do we want to overwrite? I think overwriting's fine. Overwriting's fine for now. Which probably means we might not need an allocator anymore. Oh, we might. What's this temporary stuff for? Oh, for the sampler. True. So this is base and base, base. And we don't return anything anymore because we're just doing it on top of the thing that exists. Hype. Some error shit to deal with. Now this thing should be looking at base image GPU directly. I was just calling this thing image tensor. Like, why not? Why not? Okay, so let's not run make bars and double check that we do see our little whale show up. Bad news bears. You see nothing. So can we start here? Like, what's going on here? Mem set 0 or 1.0. Which way does memset go? This way. So we memset this thing to white. Do we see anything? No. That's not good. So we create a tensor out of this guy. Then we feed him back. We like convert him back to RGBA. What's our deep data look like? Wrong. It looks wrong. Right? This should be ones everywhere. And the fact that it's not seems bad. Oh. Yeah. So we take this guy? What the fuck is going on then? What in the fuck? Are my dimensions right? I think so. Oh. I guess, we are not waiting for this thing to finish uploading here. Which means that, like, the memory in this scratch allocator might be getting, like, fucked up after that. That's possible. Yeah, there we go. 1.0 is everywhere. So now if we go back to this, does it look more reasonable? Maybe. That's a maybe. So can we not print this anymore and just look at the fucking picture? There we go. So there's our little whale picture. And then we throw the bars on top. And let's take a little peek. So he's pissed. Because integer part of floating point value out of bounds, which is interesting. Yeah, that's pretty interesting. Just for a second, I just want to see what happens if we clamp it. Min of this in 255 int from float 255. How is that not? How is that possible for this to be out of bounds? Oh, because this might be negative. Could be. Okay, so that's interesting. I wouldn't have thought that, like, drawing the bars on top of this thing would cause any real problems. Are we doing something stupid, like adding to the output instead of overwriting it? No? Okay, so before, let's just make sure that if we go back to what we were doing before, which was yo dog, should I start coding or nah, TS look buns? What the fuck are you talking about? Okay, let's create a new tensor that matches the dimensions of the input. Then we use ret here everywhere and return ret. So this is what we were doing before ish. Is this still broken? Because I don't really see how it could be. But we can check. Yeah, something's wrong. I guess it... Yeah, I don't understand. I don't really feel like we changed that much. So before we were making something that was 1,000 by 256, I guess is maybe a difference here. But otherwise, it looks very similar. So can we go back to taking in dimensions here? Just to, like, get real back to it. So this is a 1,000 by 256 is what we were doing before. And this is actually any type. Yeah, what the fuck is going on here? Comment this out. This is also unused now. True. Dims, num, elms. Oh, yeah. I guess this will be a dims for sure. And then here we will pass in somewhere this thing as, like, init. Something like this. I don't know, man. Something like this. Okay, so that's back to working, which is interesting. Right, that's interesting. So if I uncomment this stuff and just comment out image tensor B, the fuck? So just by loading this thing, this other thing is, like, no longer correct. That's crazy. I assume it's like okay, let's do this. So let's just comment this line out where we like load the tensor onto GPU. So that's fine. It's just by making a tensor and discarding it, that's fucking up the output of this other tensor. That's so fucking weird. That's so strange. Load underlying image is kind of what we're doing. That's very strange. So there must be something in like the OpenCL chain that I don't understand right now. So the way that this works is we have this like executor guy who wraps like OpenCL command queues, and like when we create hold on. Let's like just not. So when we create tensor untracked, what's happening here? We have like initial data, and we are creating tensor common, which calls create buffer, which creates CL create buffer. Okay. Then we just call write buffer untracked, which says on this queue, here is some data to put on there, and like at some point that will finish, but just like write that shit, you know, write that shit. Then we come into make bars, and we like generate a pattern that we put on this like sample buffer. So it could be that the sample buffer is fucked up, or it could be that our like return buffers is fucked. We also like try to free the sample buffer after we use it, but like let's just double check if that's causing problems. So it's definitely still broken there. And inconsistently broken, right? So then we like execute this OpenCL kernel that's supposed to like write the shit out. So let's do just like a simple thing here, and we can call create tensor here and wait for that thing to finish. Still discarding the result, but making sure that like we finish creating that first tensor before we start making the second one, which does seem to help, which is interesting. That's pretty interesting. That's pretty interesting. So I thought that these queues, OpenCL queues, that tensor isn't even used. It shouldn't affect that shit because it's being discarded. Yeah, I agree. But it could be that these queues don't execute in order like I thought they did. That's very possible. Or there's some like leaking of like as this guy is writing to his buffer, like because this is untracked, right? This is kind of happening like this is happening while we go through the CPU work over here. Right? So like make bars doesn't actually make the bars. It like queues up work to the OpenCL system to say, hey, GPU, could you execute this OpenCL kernel on this data? And I guess like maybe if that isn't like tracked well, like the way I think it is, like I guess like calling release memory here might have some effect. And then when we call toCPU, we do like queue a read onto the queue and wait for that thing to complete. So this should make everything complete in order. It should. Or like by after this point, everything should be done. Everything that we've queued. Okay. So I guess what we could do, it would be interesting to see if our like temporary buffer here of sample buffer is getting broken. There's also like there's like CL finish. So we could try making sure that everybody's ready to go before we execute our kernel. That's interesting. That's quite interesting. And I assume doing that here doesn't really change anything. Okay, that's also interesting. What about doing it like here? What the fuck? So, asking the queue to like wrap his shit up? Whoa, 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 whoa. Oh, I didn't save here, my bad. So this should be bug case. Nice. And then if I say, hey, could you fucking finish your shit up before reading? That's fine. And if I say, finish your shit up after reading, even, that's broken again, right? So that makes sense to some extent. I thought that this read buffer gets queued up on the queue after everything else. And we wait for that thing to finish, right? So like, I'm surprised that this has any effect, right? Being like, yo, clear your fucking queue here before reading does help. So does that mean that I just don't understand this queue? How is this queue being created? We have queue here comes from create command queue with properties. So let's look at this guy. I'm surprised that anything works if this is broken. Okay, so each property name is immediately followed by the corresponding desired value. The list is terminated with 0. So we have like no properties by default, right? We have a null here. So queue properties. Okay, what do we have on here? We have queue properties, queue size, queue throttle. I know there's like out of order execution? Okay. Here we go. Determines whether commands queued in the command queue are executed in order or out of order. If set, the commands in the command queue are executed out of order. Otherwise, commands are executed in order. So then the question is this set to 0 by default or what? Because we're not really intentionally setting this, right? Which maybe is a problem. Its default value, in which case the default values for supported command queue properties will be used. So how do I know what the default value is? And this is, okay, so if this is not specified, an in-order host command queue is created for the specified device. So this is what I would have thought, right? That like these things have to happen, everything we put on this queue has to happen in order. And so I don't understand why like flushing the queue before reading changes anything, right? Because like this read buffer goes on the queue after everything else, right? So like why would finishing the queue matter? Right? Unless this doesn't do what I think it does. So can it pop something from the queue, start work on that item, then pop another item off the queue before the first event completes? Yeah, that's a good question, huh? So like if reads and writes are like somehow Yeah, maybe. So just double checking. Doing this after this doesn't help, right? What about doing this finish inside here? So like after we queue up, uh, after we, what is this thing called? After we queue up the read buffer, but before we get its result, does that change anything? No. Yeah, that could be, well, okay, what is in queue read buffer? What are our options here? We've got command queue, we've got the buffer, blocking. So is this thing blocking? No. No, this is not blocking. See below. So blocking read, if the command is blocking, this does not return until the buffer data has been written and copied to memory, which is fine because we return a point, an event handle, so it should be fine. But let's just try setting this to true, just to see. I don't think that should matter. And yeah, it doesn't, in fact, it seems to be making the problem even worse. Which makes sense. Okay, then we have, you know, offset 0, size, len, pointer where we're writing to, and then like an event list that there's like things that we're waiting for, which is not reused, and then the event handle that comes out. Okay. Yeah, it could be that like that the queues do not happen like fully in order the way I expected them to. Maybe it's only start in order, but not necessarily finish in order. Yeah, it really could be that. But I would have assumed that like this buffer. Yeah, okay, let's try we could try using this like event waitlist thing. So like theoretically you have you want like make bars to return an event with him or something. So like this execute kernel. But like then why does this like generation of other thing have an effect on that? I guess it could be that like that your everything else gets kind of like bumped back a little bit. Yeah, maybe. Okay, I'm gonna put this as a thing that I don't want to think about right now because we'll just put in mind that it might be start of action, not end of action. And then do like uh we'll try to work around it for now. And I'll come back to this later because this is like a problem that needs to be fixed. But I think that the fix is like a little complicated, so let's do this. Okay, so if we go like CL executor finish here before we move on to trying to write on top of it, right? Then we have like image tensor is equal, or we pass in image tensor here. Okay. This guy goes back to returning nothing. And we start writing on top of our shit, so base here. And then we do like another Charbit, thank you for the prime, much appreciated. Okay. Okay, so we're back. We're back. And we will just ignore this for now. And come back to it because I want to focus on the stuff we were trying to get done today. So scale. Let's start by trying to render this thing kind of like centered and small so that we can like still see the other thing leaking out, right? So if we comment this make bars out, we should see our whale. Yep, okay. And now let's make it so that on make bars, we can pass in maybe a scale parameter, so 0.5. And let's figure out what to do with this thing. Presumably this makes it down here somewhere into the OpenCL kernel. And so now we have scale here. And what do we do? This like has an effect on where the module starts and ends. So we kind of want it to be scaled relative to the center, probably. So I guess we probably have like our X and Y positions multiplied by the scale, probably. Centered. So if we have like a center, this is gonna be what, like width over 2, right? And then we have like our height here, which is gonna be n over width. We have our cy is height over 2. Okay, and then like what are we gonna do with our center x and center y? We say like we have our x and y, which is gonna be global ID over width. Okay. Then we scale these, so with we either multiply by the scale or divide by the scale. We're always outputting to like our pixel. So this is going to adjust where we're sampling from. Yeah. So I guess like the module width. If the scale is 2, the thing is like 2 times bigger and the module width is 2 times bigger. Right? And when we sample from this thing, our x1 and x2 are like different now. Also, this would be times scale. Okay, what happens if we're like out of bounds here? I think that what we want to do is our sampler needs to return if we're in bounds or not. And we need to return like if x1 or x2 are out of bounds. Yeah. Okay. And so now we can go like float val if sample 1D with all this shit. We assign that to the output. Seems reasonable. And so now it's like, where do x1 and x2 come from? I don't know. Okay. So let's like run this and just see what fucking happens. So I think what I'm expecting to see here is it only go halfway. Nice. So we're still doing full vertical, but we're only going halfway up here. It doesn't look like we've rendered the full thing, which is a little interesting. Right? Like we see like the start pattern here, but we don't see the end pattern on the right. It does seem like the middle pattern is approximately in the middle of this chunk. So can we go back to scale 1.0 and see how that looked? I don't see the end pattern here either. That seems kind of like a bug. Ba-ba-ba-bum. So that's kind of interesting. Total width here is expected code length times 7 plus extra width plus quiet zone space. Okay. Interesting. So we are module width is the width of the image over the number of modules times scale. Scale is 1.0 initially. So when we're sampling from this thing, we're looking at our pixel position over the module width in pixels and the right edge of our pixel over the module width in pixels. I would be interested in, like, if we did something stupid here, like made the module width smaller. It is interesting that that looks different. Yeah, there's a bug here. Oh, you know what? This feels inconsistent again. Maybe not. This looks right now, but I don't really understand why. I feel like before sometimes, yeah, there's inconsistency. There's inconsistency still. God damn it, dude. So even after, maybe it's another one here. another flush. God damn, dude. That's so strange. Okay. Cool. Yeah, okay. I think that's better. I think that's better. Okay, so now we go 0.5. It was generating the module, like the initial module sampler. We were not waiting correctly. Okay, nice. Raise conditions to GPU, name a more iconic duo. Yeah, hell yeah. Okay, so I want this thing to kind of like, when we apply a 0.5 scale here, I guess I want like X scale here and Y scale to be separate. I think. And we can apply X scale and Y scale independently. So we apply the module with X scale, and I guess we say like, if Y is greater than height times Y scale, return, just don't do shit. So now we have 0.5, 0.5, and we should see this thing kind of like stuck in the top left corner now. Bottom left corner, interesting. Why? I think that our y's should be. I think that we like define our coordinate space, and it should be top left to bottom right. So this is surprising to me. Oh, it's because we're rendering this thing in OpenGL, and OpenGL textures are bottom up. Sure. Sure. Okay. So confusingly, we need to remember that the bottom left is zero, zero. But I would say that is scale. And let's do translation next. We'll say that like scales working to the bottom left corner is just expected behavior, so that we don't have to think about it. Right? And then translation, it should be easy. Just be like x offs, y offs here. And then when we do what? I think we do like plus x offs here and plus y offs here. I don't know why this thing's pissed. Oh, he doesn't like that it's truncating division. But that's intentional. Does this get rid of the warning? Okay. Now he's mad because we're not passing in the right arguments here, so we need to fix that. Okay. So our offsets now go here somewhere. So like this is in pixels. So like 100, 100 should bring him like in a little bit. Other way. And then we also have to check or y is less than 0. Do we handle x here? Yeah, we do. Cool. Okay. Let's parameterize this stuff. So let's put this in the GUI, where our GUI now will have these guys as parameters that we can just like adjust. So somewhere we need to put like layout, push widget, widget factory, make drag float. And this guy wants you know, x offset maybe, right? And when we x offset changes, we should be like request like x offs or something. Generate x offs, takes in a f32 and returns x offs is equal to value. This thing gets passed into this guy. So action gen is GUI action make generate x offs like this. Okay, and then the drag speed is like 0. Like maybe 1.0, maybe. Var x offs after 0.0. So as this thing changes, we say like x offs val. We say x offs is equal to val, and then we like regenerate the image, which is something that we don't do right now. Okay, let's figure this out. So for now, we have this slider that we can move. It doesn't do anything yet. We need to make it so that like this stuff that's happening at the beginning is like something that can happen at any point in the application. So I guess we have like, we're kind of like doing like sometime before now. It's like a GUI hookup. Okay. So we're gonna be like update image view. Probably. And so what does our image view come from? We have a widget for this thing, which has like a GL image inside him, right? So presumably we can just like update that GL image and everything else should kind of come for free, I guess. And so I guess we kind of like, for now, reload the image off disk, do all of this conversion shit, and create the GL image. For now. Probably. We have our math executor. I don't know. And our CL allocator. So like, where are these tensors gonna live? We can kind of do this, I think, a little bit. Executor like this. We need our barcode generator. Okay, and then we kind of sprinkle these guys around. Image CPU data. Surely this doesn't need to live very long, right? This can probably live for like this. Same with this stuff. This doesn't have to live very long, I think. Because the only thing that needs to come out of this thing is like GL alloc. I think. This is the only thing that needs to come out of here. And then we just say like image view. Maybe like the image view owns his own like allocator or something, and then we have like update or something like set image, you know, something like this. And then he just says like self alloc. We have like this self alloc reset, and then we have like a image data to GL with our allocator, and we have like image like this. Seems kind of reasonable. So then we have like image view set image CPU image like this. And then this geolog doesn't need to be here. Okay. And then the X offset comes in here. Okay, this guy needs like an allocator here, which is like image view alloc or something. We have like GUI alloc make sub alloc image view, something like this. Sure. I don't know, man. I don't know where this is going. Okay, so this guy right now gets like this GL image here, so this guy needs to live off that thing. And really, now all of this stuff should be just calling into update image view. Probably. So we should be calling like update image view with barcode gen and our allocated door and like allocated doors scratch. So much shit. But whatever. Math executor, image view, and I don't know, like this. Something like this. Okay, so then all of this stuff goes away. And now we should be able to call this same function down here. Something like this. I think that this is going to be leaking some CL memory, so I don't think anything leaks out of here. So we should be able to be like this. Just like do whatever the fuck you want, and then later we'll deal with it. What's he pissed about? Probably that this guy inside him is using CL alloc, and this is like double pointering now. Okay, does everything still work? Good. Okay, that's good news. That's doing something. That's doing something. It's slow, but we'll live. We will live. Okay, so let's I think that this needs to be like a one-liner. So can we do uh you know, image updater and just slap all this shit inside like this, right? And then we can do update like this. And he just does all this stuff, but now we throw a bunch of selfs all over the place. Every time he gets mad, write a self. Boom, 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 boom. Okay, huge. Self, 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 self. This is not great, but we'll live. Okay. So then here we have like var image view updater is image updater, and we just kind of slap all of these guys in here. So like womp womp womp. Throw some dots around. This is like this, like this. Okay, bing, bing, boom. Okay, and now it's like image view updater update. Okay, and then we can call this down here after modifying his update, his thing. So it's like x offset is equal to val. We call update, and now we just need to make sure that that widget is pulling from the right spot. Boom. Okay, sick. And so now it should be pretty easy to like add in widgets for like the rest of the stuff. So like image view updater. You know, we have our parameters here. So y offset, x scale, and y scale. Should be easy now to like just hook up here. So it's like x scale, y scale, y offset. X scale is 0.5, Y scale is 0.5. And if we just slap these things now into GUI, so this guy needs actions for these guys. Boom, boom. This is Y. We have X scale and Y here. Now we can just slap some more sliders around. Like this. So this is y-offs, x scale, y scale. Okay, let's see. We need here like this, y-offs like this, and y scale like this. Boom. Almost. Forgot some commas like this. All right. Boom, boom. So the scale needs to be adjusted by much smaller numbers. But otherwise, I'd say that looks pretty sick. It would be a lot nicer if the scale was not from the bottom left corner. It really would be nicer. But fuck it. Okay. Let's do some rotation. So let's start by throwing some generate rotation in here. Uh-huh. So when this thing rotates, we are going to be looking at the rotation on here, which means that this guy needs rotation. And let's put this guy at like, you know, just like a little, you know, stud math pi over 4 or something, or for by default. Wait, what's he supposed to do? Okay. And then we forgot to attach this to the rotation here. And so I need to make it so that when we update the image view now, that passes in rotation. So barcode generator, rotation of 32. This gets passed down all the way to the kernel that's running on the GPU. Okay. This guy's gonna get mad because he's not passing that in now. Then the kernel needs to take in the rotation. And what are we gonna do here? So our X and Y now are probably wrong. So like, let's think about this. We have positioned a guy somewhere in here. I guess if we stick with the bottom left corner being the guy, we can kind of just say, take my bottom left corner and add my x and y come from like the y-axis and the x-axis multiplied by something, but that's not how it works, right? It's we start with a pixel value in global image space, right? And we need to calculate his offset from some relevant point. And if we're going to be doing this, we might as well make that point the center. We might as well. So let's kind of like redraw this like this, right? So we calculate this guy. We have our x direction and our y direction, presumably, right? Like, probably. And we just multiply by these vectors. So do we have vec2s in this language? Probably not, right? We're not like GLSO, we're C. So I guess that means that we need like how do you do this in this language? Like this? So then we're gonna have like v2 from angle. So v2 x from rotation. I think vec2 exists in OpenCL. Oh, nice. Vec. Built-in vector data types. Hell yeah. Nice. Thank you. That saves me some time. So we have like x-axis. Float to x-axis is equal to how do you initialize these things? I assume that you can do like this. Okay, so if I am pointing up and to the right, this angle is small, so my axis direction is cos theta sine theta. Right, so this is I assume you can do this. Y-axis is going to be he's going to be twisted back a little bit by angle, so it's going to be negative sine and cos. Right? Simple. So now our x positions, we're going to be like my center offset. Center offs. So this is, we need to turn these into image x and y. Right? Which probably we should keep the old versions of these things here so that I can reference them. Otherwise I'll forget. Okay, so this is easy, right? Image x is this, image y is this. So let's take our image center x as well. So this is going to be the like width over 2, right? And the center y is going to be height over 2, which we have. Okay. And so now we can be like, what is our offset from the center? Right? So I guess it's like image center x plus x offset is like barcode cx and barcode cy, maybe minus actually. No, plus. Plus makes sense to me. Okay, and so now we calculate like our offsets to these things, right? So like Um, okay, so like so now we have we have these two arrows, and we need to like dot product, I guess, our offset onto those axes. Onto just the x-axis, probably actually. Because then we use that for sampling. I guess we need y as well for this as well. Okay. So I guess we just have like x is like, do they have dot product in here? Dot. They just have dot in here, which is kind of nice. Only integers though? They have dot float product dots. Okay, cool. So this is gonna be like like x offs is gonna be like image x minus barcode cx or something. And then we have like we dot product our x offset onto the barcode x axis. So this should just be offs, really. Right? Kind of like this. Right? Like this. Then we just dot product our shit onto our axes, which should already have lengths of 1 automatically. So I think that makes sense. And then is the rest just like kind of free? That's like shockingly close. Shockingly close. And then it actually looks like our interpolation there, it looks whack because we're not doing any like anti-aliasing, but it is like not really that wrong either. Womp. So I would have thought that our center shit would have kind of helped us here. Are we even, so we have like barcode center X is the image center X plus X offset. Is it because we're applying like scale in the wrong spot? No, because this should be allowed to be negative. So we might have like y is the dot product of, oh, are we not adding something? Do we not need to add the barcode center X and barcode center Y here? No. Okay, what's happening here? So we have our image X is where we are. We say we are relative, like we have been offset from that spot from the barcode center. Oh, this is probably barcode bottom left, huh? Hold on. So if we set this to like offsets to 0-ish, I assume that that'll put the bottom left corner in the center of this image, which it is. Yeah, I see. I see. So this is like, something like this. That might be the wrong way. Oh, this is width and height of the image, though. What doesn't he like there? Okay, I'm doing something wrong. Why not? Why doesn't this work? So my X position. So if the thing is centered, if it's centered, right? We are, our pixel is like some offset from the image center, right? So his X position in barcode code coordinates, I guess, is like relative to this edge, and his Y coordinate is relative to this edge. So we need to convert our XY into this, right? So here we say, hey, I am offset by like negative this amount. Okay, so if I'm like, let's say here, right? We're right here. I'm offset by this amount. Is it that the center barcode here? So plus the center barcode. Yeah, so I'm offset by this much. And I need to like subtract the left edge or something. I think that's what it is. Something like this? Then we subtract this from here. No, because this offset is relative to the center, but this is like, it's not relative, like this is just like a movement. So in barcode space, it should be like apply this movement relative to my center. Can we change these to like barcode cx image space? Barcode cy image space, and then barcode cx barcode space is like, we have like barcode width here should be float width times scale, right? And the height should be the height times the y scale. And so we have like barcode cx barcode space is barcode width over 2, right? And the center y in barcode space is the height over 2? That seems reasonable to me. So then my x position is how offset we are from the center plus the center in barcode space. I think. That's how it makes sense in my head, which might just be wrong, but... Oh, there we go. That's working. So he's rotating around the center now, and if I put 0, 0 here... and set the scale to 1.0, or like just under 1 in both dimensions. Now, if I line this up, I can't tell if there's warping going on, if it just looks like that's the scale. I think that feels kind of right, no? That feels right to me. I think the warp look is coming from like weird aliasing shit, like just the way that that stuff is kind of sliding around looks kind of weird, but I do think this is doing the right thing. It's crazy that we're gonna have to implement anti-aliasing. Like, this looks so bad. So it's either like our blending is bad or our anti-aliasing is bad. But I don't really know how to solve that, and I need to like look it up. So I'm gonna not do that right now. So what would be nice now, I think, is to try to like match the color of this thing and like make it so that it kind of like fits the overall stats of the image, right? So that we can like kind of put it anywhere and have it look like it kind of fits. So maybe we like just super sample the shit out of it. Yeah, maybe. I have to figure out how to do that in OpenCL, but I do agree that is kind of like that is what like MSAA is, right? They just like break the pixel grid into 8x. You'll downscale the train anyways. Yeah, but I think that like it being super fucked up looking, then downscale does have an effect. I suspect that like, and then also I believe that the we're gonna have a high res version of this thing for barcode for like, how do I say this? Like, you kind of want like a low res version of this for like barcode isolation. You know what I mean? So like finding the barcode in the picture, you want something like tiny, right? But when you're actually looking at the bars, you probably want something relatively high resolution, right? Probably. Or else like you won't be able to see the important details of like where the bars are. I guess you can like find them pretty well at even like pretty low resolutions here. But whatever. Okay. Yeah, let's do a thing where we color match. So I guess that involves taking some form of like statistics over where the barcode is gonna go, probably. Right? We kind of want this to match the overall color of the stuff it's replacing, which seems kind of like unless we want to go back down the road of doing like GPU parallel sums, it feels like a CPU problem, right? So like we probably like select where the barcode is gonna go. Then like sample that area. Let me think for a second. Yeah, so you like decide where the barcode's gonna go, you sample that area, take like the probably standard deviation and mean of that section, and then choose the light and dark colors based off of that. Is probably what we do. If you assume that like the area has high, maybe not actually. Because like what if you choose like a light section of this area, but like that doesn't mean that it's like the darkest thing that could be shown in that area, if that makes sense? It depends on if you assume that like things are blown out because they match. Sorry. I guess what we could do instead of trying to match is we could just randomly pick a dark and light values kind of, and within the distribution of all images that we'll see some that kind of blend in. Right? Let's do that. Let's do that. That seems reasonable. So let's say we have like dark. I guess the dark and light, I guess, kind of comes in on the module generation, actually. So this is actually kind of CPU-y, surprisingly. So we probably have like a, where is this? Barcode generator. We start by on CPU generating the codes, and I guess here we just take in dark and light color. And we multiply that somewhere. So everywhere we have like 1.0 here, we replace this with light color. Oops. Okay, and then everywhere we have 0, this is dark color. Okay, and then this pattern shit. So when we are reading from the pattern, this is light color times the value. This is just like ones and zeros. And then here, it's the dark color times V. And I think that kind of like makes it all work out. So now we should be able to go into our GUI stuff and set like light color and dark color here. And slap those into here. I assume we did dark light, but you never know. Make bars, we do dark light. Yep, look at us go. And then, so we need to like attach actions, these guys. So we have dark color and light color. Okay, these guys have GUI actions associated with them. Like this. We have light and dark here. These guys get like actions here. And then when these things happen, we ask for them to happen. So dark results in an image update after we update the dark color. And light updates the image view thing after changing light color. So when we create this thing initially, we have light color is 1.0, dark color is 0.0. And hopefully now we can just kind of change these things. That's pretty funny. We've definitely fucked something up. That's pretty funny. So when we start, we do light color. Then here we say, I mean, it looks like, is it like 1/2 is wrong? Kind of feels like it. Rotation, let's just set the rotation to 0 here. So it's like the right half is kind of fucking busted. So, oh yeah. So we need to like interpolate. Kind of. It's like if V equals 1, then it's dark color, else light color. And then here we need to do if V light color, else dark color. If we do a comp time in here, I think that like makes the stuff nicer. Pattern. Oh, fine. Okay, nice. So now we can kind of adjust these guys as we want. So like we could try to color match this a little bit, right? Like look at that. Look at that. Everyone, no. There we go. Look at that shit. It's not bad. It's not bad. Now, I guess the last piece here, we could do like randomization. So what we could do is we could make it so that when we punch in, we have like a random seed maybe that we feed into GUI somewhere. These guys should all have labels, by the way, but we're lazy. Eventually, I will regret this. I think this is actually going to be an I32, I guess, which means that this should be make drag, who can work with integer types. So here we just say like usize, I guess. I don't really know what we support here, so we're gonna have to get careful. Drag mul and drag div. So I guess like every pixel, we're gonna try to move by like maybe every 5 pixels, we increase the seed by 1 or something like that. Return seed is val, and we said this is gonna be a usize. And then we have here, seed usize. Here, we change the seed. So we say, image view updater, could you set the seed to val, and then re-roll, maybe? Then update? Right, so maybe on re-roll, we look at, we create like a new RNG. From scratch. So stood random default p RNG initialize with our seed. Is this the right type? U64 is actually what he wants. So we'll do this, and then we just say like for each field that we want to randomize. I guess it's like, can we do this? Okay, so for each of these guys, we do, we need like the random interface. We go like, field self, field is equal to RNG interface float. And I guess probably 0 to 1 is not what we want for all of these, actually. So maybe we actually do it manually. Self rotation is this times stood math pi times 2. We got x offs. We're gonna go like minus 0.5 times width, which we don't really have here. Image view, I guess we kind of have it. Image view, image width. Okay. X scale is gonna be, we're gonna make these configurable ranges eventually, probably, but for now, I think RNG float is good for X scale and Y scale, just anything between 0 and 1. Light color and dark color. I think we actually want to do like mean color is, you know, then we probably want to like clamp this, right? So like maybe the mean can't be less than 0.2, right? Uh, yeah, and maybe we want it to be like no greater than 0.8. And then mean offs is, something like can't be smaller than, again, like 0.2, which means that we need to like times this by 0.8 or something. Something like this. Then we have light color is mean color plus mean offs, and then we have dark color is this minus mean offs, I guess. Something like this. Fuck off. Val retriever must be a U size or a struct with get val. Oh, true, because we changed that thing from U size to U64. Okay, so when I... Oh yeah, look at that. Look at that. That's kind of hype. They're all very bright, right? So randomization parameters might need to change. We also might want to like limit like the aspect ratio and shit like that. But that's pretty sick. That's a good starting point, I think. And that brings us to 350. So we didn't really get to much of the like fucking the barcodes up, but we did get to randomly placing them, which is pretty huge. This obviously needs like a lot of cleanup, and I think that it's likely that we might actually want to like go a little farther and target something a little better. So like yeah, what are the fix me's here? So it's the queuing of GPU actions. It's parameterized random values, right? We need to fix that a little bit. Make it so that like, stuff like this can't happen where it's like off frame and stuff. And then also we want, there was something else. Oh, like general code cleanup. But, this is pretty sick. Pretty sick. So I guess tomorrow we should come back and try to do something that's like fucks up the barcodes a little bit more aggressively. To get more in line with some of this stuff. But for now, I think this is good. So thanks for watching, guys. If you like what we saw, we stream most days. We aim for 12:30 Pacific time to 4 o'clock Pacific time. It is 3:50 now, so anywhere between 3 and a bit hours ago to a bit from now if you're watching live. If you're watching on YouTube, some segments of the streams goes up there. Some do not, right? So like today, I think we were working on a little bit of fixing kind of like right-click identification here, right? So if I click here, I want this to say 00, and if I click over here, I want him to say 1024.683, which I think should happen if I click on the right spot. Close. I guess 10, 23, 682 because it's zero index, right? So we were working on this today. So stuff, sometimes we have like cleanup work to do, minor improvements, stuff that I don't think is like worth a YouTube video. And so we kind of work on those in like another segment. And if you want to see the VODs of those segments, we post them on Patreon or in YouTube members or on Twitch. And if you support on whatever platform, you get access to the rest of the VODs if you can't catch them live. And the knowledge that you are helping contribute to the stream continuing, right? Because my money is decreasing over time, and when I run out, I have to get a job, and the stream will stop happening. So this is kind of like the way we can say, if you guys want to make sure the stream continues, every dollar I make does directly increase the lifetime of the stream. So please consider, but obviously, if not, no big deal. I think that's all I got to plug. YouTube, peace out, and Twitch, let's find someone to raid.